Imagine talking to an AI, but what if its memory was wiped completely after every single sentence?
No. Yeah.
Or it simply couldn't learn new things beyond its initial training, ever.
Yeah.
That. Well, that was the fundamental challenge. Welcome to the deep dive. Today, we're unpacking a really crucial shift in the AI world. We're moving beyond just, simple prompting to truly engineering context. We'll explore how AI evolved from those flashy demos to powerful, reliable systems that you can actually build products with. Our sources for this deep dive, they're compelling excerpts from a piece called Prompt versus Context Engineering, Building AI Brains, and they reveal some genuinely surprising insights. So get ready for those subtle aha moments about how AI actually learns and operates.
Yeah, and this deep dive is really for anyone keen on understanding the actual brains behind AI. It doesn't matter if you're crafting new products or maybe you're just curious how these intelligent systems function. It really lays out the path toward truly intelligent, sustainable AI, the kind we can trust.
Okay, let's unpack this then. In the early days of generative AI, everyone was absolutely mesmerized by prompt engineering. It felt a lot like magic, didn't it?
Oh, totally. Like
Yeah.
finding the perfect incantation or something.
Yeah, just a few carefully chosen words, and boom, you get a poem or a piece of code or a whole business strategy.
So much power in such little text. It was pretty wild.
Prompt engineering, well, at its core, it's the discipline of designing and optimizing instructions.
Hmm.
Instructions to guide a large language model, an LLM, toward a desired output. It operates at a very micro level. You're refining each individual interaction.
What's truly fascinating here is how just a few clever words suddenly wielded so much influence, like discovering a secret language that only you and the AI knew.
And it wasn't just like typing a simple question. There's a distinct anatomy to a really perfect prompt.
Hmm.
You start by assigning the AI a role, something like you are an expert in personal development.
Mm-hmm. Giving it a hat to wear.
Exactly. You give it a clear task, what exactly you want it to do. You provide context, that crucial background info, and even examples, which is sort of one-shot or few-shot learning, helps it get the style or format you're looking for.
Right, showing it what good looks like.
Then you specify the output format, maybe you need JSON or bulleted list. And finally, the tone, the linguistic style, like inspiring or maybe strictly professional.
So, okay, instead of just saying, write about the benefits of reading books, you might build something way more precise.
Exactly. You might construct something like, role. You are an expert in personal development and a best-selling author. Context. I'm writing a blog post for young adults. The ones who feel they don't have time to read.
Mm.
Task. Write about the top 3 benefits of forming a daily reading habit. Focus on career growth and mental well-being. Tone. Use an inspiring, persuasive, yet relatable tone. Output format, present this as a numbered list, with each benefit explained in about, say, 50, 70 words.
Okay, wow.
The difference in output quality between that simple prompt and the optimized one, it's just stark.
Yeah.
Huge difference.
Yeah, I can see that. So if the basic prompt structure was powerful, but then problems kept getting more complex, how did prompt engineers push things further? Like, what were some of the clever tricks they came up with to get the AI to sort of think deeper?
That's where the advanced techniques came in. And this is where it starts to feel a bit like teaching the AI how to reason. One is chain of thought, or COTI, prompting.
Okay.
This is basically just requesting the model to think step by step before giving a final answer. It's incredibly useful for logic problems, math stuff.
Yeah.
It helps minimize those really frustrating errors.
Right, it's like asking the AI to show its work, almost like in school.
Exactly that. Then there's self-consistency. That's where you run the same prompt multiple times, letting it generate different internal thought chains, and then you just choose the most frequent answer. Helps boost reliability.
Ah, safety in numbers. Makes sense.
And even more advanced, there's tree of thoughts, or TOTI. This lets the model explore multiple reasoning branches at the same time, and it kind of self-evaluates which path looks most promising.
Ooh, okay. Like a mini brainstorming session happening inside the AI itself.
Pretty much.
Oh.
But despite all this power, prompt engineering, well, it quickly hit a kind of glass ceiling. The inherent limitations became pretty clear, pretty fast.
Like what?
First, statelessness. Each prompt was totally independent. The model had zero memory of previous interactions, even in the same conversation.
Right, like talking to someone with severe short-term memory loss. Every sentence starts fresh.
Exactly. And I still wrestle with prompt drift myself sometimes,
Yeah.
Trying to get that consistent output from the exact same prompt can be tricky.
Yeah, you ask it the same thing 5 times, you might get 5 slightly or wildly different answers.
Frustrating. Then there's the knowledge cutoff. The model could only answer based on the data it was trained on. couldn't access real-time information, or, and this is crucial for businesses, internal company data.
Mm-hmm. Stuck in the past, essentially.
And finally, difficulty in scaling. Manually fine-tuning prompts for every single scenario, every possible user. It just isn't feasible for large-scale real-world systems.
So, okay, prompt engineering hit this glass ceiling. What's the core limitation then of even a really well-crafted prompt?
A prompt is stateless. It lacks memory beyond its current interaction. And these limitations, well, they were fertile ground for a new discipline to grow: context engineering.
Okay, so if prompt engineering is like asking a really smart, very specific question, context engineering sounds more like building the entire library and the short-term memory for the person answering.
That's a great way to put it.
It's a systems architecture discipline, really, focused on managing the entire flow of information an LLM receives. And context here means way more than just the user's prompt. It's everything inside the model's context window right at the moment it makes an inference.
And that context window is the limited amount of text an LLM can actually process at one time. Right?
Exactly. So we're talking system prompts, the chat history, data pulled in from external databases, that's RIG results from API calls, tool use, and even user-specific info. It's all about strategically managing that really precious, limited space.
Which brings us to its 4 pillars. Right. Pillar 1, memory management. This is the direct fix for that LLM amnesia problem we talked about. A context engineer designs systems for both short-term memory that usually stores recent conversation history, often summarized to save those precious tokens.
Tokens being the sort of words or pieces of words the AI counts.
Exactly. And also long-term memory. This stores important user info or past interactions, usually in a vector database.
Okay, vector database. What's the simple take on that?
Think of it like giving every piece of information a unique fingerprint based on its meaning. So the AI can instantly find other info with similar fingerprints, even in a massive library. When needed, that info is quickly retrieved and sort of injected into the context.
Got it. So you're building the AI its own personal instant recall library based on meaning, not just keywords.
Precisely. Pillar 2, Retrieval-Augmented Generation, or RAG. This is honestly one of the most powerful parts of context engineering. It lets LLMs access external knowledge sources. It directly bridges that knowledge cutoff gap.
How does that work, like step by step?
Okay, so the RAG workflow starts when you ask a question. The system takes that question and embeds it. It basically turns your words into a unique numerical pattern, a sort of digital fingerprint of the query's meaning.
Okay.
That fingerprint is then used to search a vector database for relevant chunks of text. Those chunks are then augmented, meaning they get cleverly inserted into the context right alongside your original prompt. Finally, the LLM generates an answer based on both your question and this new provided knowledge.
The benefits here are just huge. This fundamentally changes the game for trust and accountability. Suddenly, the AI isn't just making things up, potentially. It can access the latest info or proprietary stuff like internal company docs. And crucially, it can often cite its sources.
Yes, massive for business use.
Absolutely. Huge leap for enterprise adoption, where, verifiable facts are completely non-negotiable. Whoa, just imagine scaling that. 1 billion queries? Maybe. Each one augmented with real-time verifiable data. That's really powerful stuff.
It's like giving the AI a research assistant and a fact checker, all rolled into one process.
Oh.
Okay, pillar 3, tool use and function calling. This lets LLMs go beyond just shuffling text around. It gives them actual tools to interact with the real world or other systems.
Tools? Like what kind of tools?
So an engineer defines these tools, maybe a function like get weather city. When the LLM sees a request that needs a tool like that, it generates a structured function call, usually in JSON format. An external system then executes that command, calls a real weather API, for instance, and the result, say, sunny 32 degrees C, gets fed back into the LLM's context.
Ah, okay.
Then the LLM uses that result to formulate a natural language answer. So if you ask, what's the weather in Hanoi tomorrow? The LLM figures out it needs get weather, generates the call. The external system gets the sunny 32 degrees C data, and the LLM replies nicely.
Gotcha. So it can actually do things, not just talk about things.
Exactly.
And finally, pillar 4, system prompts. These are kind of like the meta instructions, right?
Yeah, they persist throughout a whole session. They set the foundational rules, define the AI's persona, its overall goals.
It's the North Star, basically, the thing a context engineer sets up to make sure the AI stays on track and behaves the way it's supposed to.
What's the key advantage, then, of context engineering for AI reliability? Why should we care?
It gives AI memory and real-time knowledge. making it trustworthy.
And this is where the mindset really shifts significantly, wouldn't you say?
Oh, absolutely. A prompt engineer. They're kind of like a brilliant writer or maybe a linguist. They're fantastic with words, crafting that perfect query. But a context engineer, they're much more like a systems architect. They don't just write the script for one scene. They're designing the entire stage, directing the whole play, orchestrating the entire performance from start to finish.
Yeah, the workflow of a context engineer really highlights that architectural role. They start by clearly defining goals and constraints. Like, what precisely does this AI agent need to do? Is it a customer support chatbot? And what are its limitations? Things like token limits
Right? The max text the LLM can handle at once.
or latency requirements, maybe API costs. These define the playground, the boundaries.
Yeah, it's about understanding the mission completely before you even start building anything. Makes sense.
Then they design the context pipeline. What data sources are actually needed? A knowledge base, user database, third-party APIs. And when should that data be retrieved? Maybe only when a user asks about a specific order. And how will that data be processed before it even gets near the LLM? Maybe you need to summarize a long chat history first, or retrieve just the top 3 most relevant RAG chunks.
It's like meticulously mapping out every piece of information, how it flows, what happens to it, all before it even touches the core LLM brain.
Next, they build and integrate. This often involves using frameworks, tools like LangChain or Llama Index.
Which are basically toolkits for building these kinds of AI applications, right?
Exactly, toolkits to connect all the components, the LM itself, the vector databases, API calls, maybe even different microservices.
Okay, microservices, briefly.
Think of it like breaking down a big complex system into smaller, independent, specialized teams. Each team, or microservice, handles just one specific part of the big project really well, makes things more manageable and scalable.
Got it. Specialized units.
And they write the logic to orchestrate that whole information flow, deciding exactly when to use ARG, when to call a tool, or maybe when a simple, direct answer from the LLM is enough.
And finally, they debug and optimize. And this sounds way different from just tweaking a prompt.
Oh, totally different. Debugging here means inspecting the entire payload being sent to the LLM. You're looking at everything.
Like what?
Is the system prompt correct? Are the RGA chunks actually relevant, or are they noise? Is the conversation history being cut off too early? Are there errors when calling those external APIs that are breaking the flow?
Wow, okay. Much more complex.
And optimization focuses on that tricky balance between quality and cost,
Yeah.
making sure there's enough context for a good answer, but without blowing past those crucial token limits and driving up costs.
Yeah.
So how does debugging a context-aware system differ fundamentally from debugging just a simple prompt?
It means inspecting the AI's entire information flow, not just the words.
Sponsor read provided separately. Placeholder. So what does this all actually mean for us? We've seen these two distinct, but deeply connected disciplines at play here.
And if we connect this to the bigger picture, this distinction is absolutely crucial. It's fundamental for building truly robust AI, the kind you can genuinely rely on, especially in critical situations.
Let's lay out some of those head-to-head comparison points we saw. The metaphor, for instance. Prompt engineering is like a scriptwriter, maybe a copywriter. Context engineering, though, that's more like an AI neurosurgeon, or maybe a grand stage director managing the whole production.
Yeah, I like that. And the scope reflects that. For a prompt, it's just a single interaction. But for context, it's the entire session, the AI's ongoing cognitive experience, if you will.
The goal, too. Prompt engineering aims for the best response for one specific query. Context engineering ensures stable, reliable, and intelligent performance across thousands, maybe millions of interactions.
And the tools are worlds apart, right? Prompt engineers might use a text editor, maybe a simple testing playground. Context engineers, they're working with complex frameworks, vector databases, RAG systems, even intricate microservices architectures.
And the mindset difference is key, I think. Prompt engineering asks, how do I ask this one thing correctly?
Whereas context engineering asks, how do I make sure the model knows everything it needs to know to answer anything correctly, reliably over time?
It's a foundational difference.
But it's really important to stress they're not in competition. Not at all.
Definitely not a competition. They're really two sides of the same coin. Inseparable.
Precisely. It's an inseparable symbiosis. Prompt engineering will always, always be key for that effective micro-level interaction. A finely crafted prompt is still the essential heart of every single request you make to an LLM.
But that heart needs a healthy body to function properly,
Right,
right?
exactly. Context engineering is that body's circulatory system, its nervous system, its very skeleton. It provides the memory, the real-time knowledge access, and the ability to actually act in the world. That's what transforms an LLM from being, a wise parrot that just repeats or rephrases things into a real problem-solving agent that understands context and performs complex tasks.
So prompt engineering gets you that first good result, that initial wow.
And context engineering ensures the thousandth result and the millionth is still good, still relevant, and genuinely intelligent.
Looking ahead, maybe as models become even more autonomous, the line might blur further, but that fundamental principle seems like it'll remain.
Yeah, I think so. To build truly powerful, reliable AI, we absolutely have to shift our thinking, moving from just giving commands towards architecting their entire worldview. That's the real journey here, from being a prompt engineer to becoming a context
It's
architect.
a fascinating evolution to watch, isn't it? We really hope this deep dive gave you some new insights, maybe a new perspective on the unseen architecture humming behind the AI tools you interact with every single day. Thank you for diving deep with us. Until next time, keep being curious.